So we're going to be diving in to exponentials and log equations and inequalities. It's really not that bad. It is where you're actually solving and evaluating. Okay, so up first, so let's consider the equation 2 to the x equals 64, right? 2 to the x equals 64. That means you're asking yourself, what is x, right? What would x have to be to equal 64, correct? Or the equation log base 3x equals, log of 3x equals log of x minus 8, right? Again, you're asking yourself, what does x have to be for these two logs to be equal to each other? Okay. What we're going to be doing is using one-to-one properties to evaluate them, okay? One-to-one property is saying that if for an exponential, if the bases are the same, all you have to do is set the exponents equal to each other, the powers equal to each other. One-to-one property for log is saying if it's the log of the same base, all you're doing is setting the arguments equal to each other, okay? So for example, if you look right here, it says 2 to the x minus 5 equals 64. Well, what we want to do is put 64 in terms of 2 to some power, okay? So you want to ask yourself, 2 to the what power is 64? And again, it makes me, I don't know why. As you can see, I really was circling. So we want to ask ourselves, 64. How can I put that in terms of 2? 2 to what power equals 64? Well, 2 to the 5th, right? So if you go through it really quick, 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 8. 2 to the 4 is 16. 16? No, you need 6. 8 squared. 8 times 2 is 16, right? It's not 8. It's 2 to the, yeah, it would be 2 to the 6. And then 16 times 2 is 32. 32 times 6, 32 times 2 is 64. So it's 2 to the 6. Now that your bases are the same, all you're doing is setting your powers equal to each other. So you're asking yourself, x minus 5 equals 6. What is x? 11. You're so smart. Okay. Does that make sense? Okay. So when you do it for log, you have to make sure it's just the argument. So before I do anything here, I'm going to have to apply the exponent property or the power property, and I'm going to have to turn my coefficients into powers. Okay, so that means I have x to the 1/2 is going to be equal to 2 squared. Okay, so if I have x to the 1/2 equals to 2 squared, that means it equals 4, right? And how do I cancel out a half power? Negative. You square it. If I have a half power, I'm going to square it. What I do to one side, I do to the other. So this cancels out, and therefore x equals 16. Okay, so that's our goal when you are using the property. Yes. It would have to be something you can easily count out and not spend a lot of time trying to math your way through it. Hit refresh and it should be updated. All right, here we go. So example number 2. You wanted to teach it? Is that what you said? Oh, just checking. All right, so example number 2. We have 24 times 1/2 to the x third equals 6. Okay, so the first thing you need to do is to get our exponent by itself. So in order to isolate the exponent, that's our first goal, is to isolate. What do I need to do to isolate the exponent? How can I move that guy? Divide. I'm going to divide both sides by 24. So now I'm left with 1/2 x to the third equals, what does 6 over 24 reduce to? 1/4. Okay. Now your goal is to find a common base. So our goal is to find a common base. How can I make 1/2 and 1/4? I can't really change a half, but can I change a 4? What could I do to a 4? How can I rewrite? Anyone? What's 6 now? 1/2 to the 2. There we go. So we find a common base. So this one is going to stay a half to x third equals now 1/2 to the 2. And then now all you're going to do is solve your exponents. So you have x over 3 equals 2. So x has to be 6. The tricky part is going to be making them have the same base.
So whenever there's like two fractions of the same, you can automatically, you don't have to, they just automatically cancel.
Yeah, so once your bases are the same, all you're left to do is worry about the power.
So they automatically move down. There's nothing you can do to move down.
Yeah, you're just solving this. This is where the unknown is. Just worry about the power. Solve exponents. All right. Now for the next one. For a log, first thing you want to do is make sure to apply the power property. So step 1 is to apply your power property. Power property says that my coefficients can become powers. So we have log base 3 x squared equals log base 3 4 to the third. Are you good? Are you with me? And then step 2 is solve only the arguments. So you're going to set arguments equal to each other. Your arguments are what's inside of the log. Equal to each other and solve. And solve. It's just one big step. So here, my argument is x squared equals 4 to the third. So we have x squared equals 4 to the third is 64. So x has to be 8. Now, because I took the square root, technically x could also be -8, but it doesn't work in the problem. Okay? And that's because you can't have a negative argument. So this is what we call an extraneous solution. So this is our real solution. Because you can't, this x, when you take the square root, it produces a positive and a negative outcome, right? It's that plus or minus situation. But the negative can't be used because your argument can't be negative in the original. So if I plug that back into the original, it was like, uh-oh, error, error. All right. Okay. Any questions so far?
So
if an argument is negative, so if the argument, if your argument is negative.
So why did you make it? It's not negative. So why did you make it? Why is it x equals -8?
Because when you take the square root of 64, it either can be a +8 or a -8. +8 is our real solution. -8 is our extraneous solution.
Extraneous?
Extraneous. So it's an extra that can't be applied. You would choose a root. It'll maybe. I mean, it was said last year a little bit. All right. Next, we can use the definition of logs to rewrite exponential equations in order to solve, right? So being able to translate your log into an exponential is still pretty useful. So let's see what happens. So this is saying what? How can I write this as a exponential? Huh? Okay, 2 to what? There we go. 2 to the 5th equals 4x. It's your base result equals your argument. Base result equals the argument. So it's asking you 2 to the 5th equals 4x. 4 times x. 2 to the 5th is, what do we determine? Was it 32, right? 32 equals 4x. And then that gives us what? X equals 8. All right. Number 5 is an example of where we're going to use all of our properties because in order to solve, you want one log. Okay. So if I want one log value here, which property will allow me to combine? The product property, right? So the product property is what I'm going to use. So using product property, this becomes log of x times x plus 15 equals 2. Remember, when there is no base, it's common log. So your base is 10. So this is saying 10 to the 2nd power equals x squared plus 15x. And then it becomes 100. When there isn't a base, it's called common log, which means your base is 10. And how do you solve a quadratic? You can use quadratic formula or factor. There we go. Minus the 100 and factor. What multiplies to give me a negative 100, but adds to give me 15? 5 and 20. What kind of 5 and 20? Negative 5 and a positive 20. Huh? What multiplies to give me negative 100, but adds to give me 15? So that means we get x equals positive 5 and x equals negative 20, which is my real. This is my real and this is my what? Extraneous. That's because I would have a negative 20 alone in a log. And is that allowed? No, your argument can't be negative. Yes? How do we feel so far? We would have finished today if we didn't have 15 minutes less of class, which is frustrating.
Something like this.